Hello everyone, my name is Nunez-Iglesias, and I'm here to talk to you about napari, which is an n-dimensional image viewer in Python. So in this talk I'm going to tell you about what napari can do, and then I will tell you about how the project is run and where we're going with the project. And I'll tell you this in the hopes that you will also join the project and contribute to it. So napari first is an image viewer. And it is very fast thanks to an OpenGL canvas, which is provided by VisPy, another open source project that we make use of. So this image is 5,000 pixels by 7,000 pixels, and the canvas actually supports up to 16,000 by 16,000 on most laptops, so you don't even need fancy hardware for it. OpenGL is really performant, and so looking at your images is buttery smooth, really nice to use. But in addition to 2D, we also can do ND, 3D and up to ND. So whenever an image has higher dimensions, napari will put a slider at the bottom, or as many sliders as it needs to display the image and display every part of the image. And if you switch to 3D mode, it'll remove one of those sliders and change the canvas to a 3D view, as you can see behind me. In addition to being n-dimensional, napari has layers. So that means that you can look at different channels, or in this case, different stages of processing. So for all the nuclei behind me, we've also got segmentation masks, and napari can display those overlaid onto the image. And we also have the centroids of each of those masks. And again, we can add an overlay, and you can turn each overlay on and off as you wish to see the different stages of processing of a pipeline. And we found this really useful to essentially test your processing as it happens, rather than having to work backward from a final result of a complicated pipeline. Napari also has support for large field of view images, but using multi-scale data formats. So if you have the right data format, then napari can load it as a multi-scale image, and you're able to browse it just like you would any other image. And finally, we have dynamic loading from disk or from remote data. So this is a lattice light sheet dataset, which has 3D plus time dimensions, and it's 125 gigabytes on disk. So you would normally have some trouble trying to display it, but with napari and the RAL file formats, napari is able to load on demand as you move the slider and load different time points, so you're able to look at your full data set very smoothly. One of the things that we really try to focus on is to have really good integration with the rest of the scientific Python ecosystem. So what you're seeing here is a PyTorch neural network that is training as we are viewing it. And so we see the output of the training as it's happening. And we also have a matplotlib canvas that is showing you the neural network loss as it's happening. And we can do this because both napari and matplotlib have a Qt front end, so you can mix and match these things together. So generally, if you're already in scientific Python, it's very easy to get started using napari. And speaking of already being in Python, if you have anything that already loads your images or your data as a NumPy array, then it is really easy to add a plugin to napari such that it will automatically use your code to load files as you drag and drop them. So I'm showing behind me a Nikon ND2 file using a plugin that was written by Draga Donsilipop and Abigail McGovern, two students that are working with me. And so by creating this package, which is not part of napari proper, but rather is an externally managed package that you install separately, then you're able to drag and drop ND2 files into napari and view them. And this in particular is doing lazy loading from the ND2 format. So even if the file is larger than your RAM, you can still look at it in napari. And there's also a tracks plugin. And in fact, there's many plugins written by the community, including plugins for Carl Zeiss CZI files and for LIF files. And the latest thing that we can do is add elements of functionality to the graphical user interface using plugins as well. So again, writing a package that's separate from Napari, you can expand the functionality of Napari to do different things. In this case, this is a plugin to create correspondence point matches between different imaging modalities and then do an alignment based on those correspondence points. And with just 3 points, we can do an approximate alignment, so you can start to see how the images align, but it's not perfect from just 3, so you can keep adding points in order to refine the alignment. And eventually you'll converge on an alignment that you're happy with, and then this will save that alignment to disk. But obviously the sky's the limit when it comes to the different plugins that you can do. And we hope to have many more plugins added over time. Okay, so now on to how Napari is developed. Napari was open source from day one, so it was out in public even from the very first code commit. It was started by myself and Loic Royer at the Chan Zuckerberg BioHub, together with Kira Evans, who was an intern in Loic's lab. And then Nick Sofarniev and Tally Lambert joined a bit later, but they have contributed the bulk of the code now. They are both amazing. But you can see many more contributors under them. In fact, 70 people have contributed to the code so far, mostly people from around the world that we don't have any contact with. They just see the code and they are able to submit fixes. And that might be you if Napari is not doing exactly what you want. And we're definitely very happy to help guide you in making contributions. Now, in terms of where Napari is at, it is still a Python tool, and so you will want to use Napari if you're already using Python. You don't have to be a great Python developer. You can just use Python a little bit to try different analyses. Then Napari will be really good for you to look at the steps of your analysis. But if you don't know Python, it's still a bit hard, but we do have a very large group of people now who are comfortable with Napari. And if you go to the image.sc forum, which is a forum for support for all of these fantastic tools, Napari is in there, the Scikit-Image project is in there. So if you need any help getting started, please go to this forum, image.sc, and ask questions. We would be very happy to help you. In terms of where we're going, we don't want this to be only for people who are using Python. We are actually working on an installable app, and it does exist now. It's just still experimental, but we are working really hard to make sure that even non-Python users can install Napari, install plugins, and make use of the whole Python ecosystem without having to learn Python. And Napari itself has a built-in Python console, so you can sort of learn Python by steps rather than having to, become familiar with Python before starting to use it. So you can go and play with this at that URL, github.com, napari/releases, and try it out. And so lastly, I would just ask you to join us, and there's lots of ways for you to join us. The Napari Twitter is a great place to see, to get inspiration to how people are using Napari. You can see there's just all kinds of cool stuff happening in the ecosystem now. Again, you can ask questions on image.sc. We have a chat room that anyone can sign up publicly. We also have developer meetings, and we have core developers in Europe, the US, and here. And so essentially 24/7, there's someone monitoring that chat to help you. And we have meetings with European time zones as well as US time zones on alternate weeks. So you can find out more about that in the Zulip chat, and look forward to hearing from you.